Okay, in this lesson I'm going to run through differentiation and turning points, or stationary points as they're sometimes called, and how to find them. Now, briefly, I'm just going to explain what differentiation is about. So, if you have, I'm going to compare two curves here. Okay, we've got a straight line, cuts through at 2. So that's y equals 2x, which is a straight line. And then I'll do quadratic, just a simple quadratic, cuts through at 0, and that's y is equal to x squared. Okay. So, when you differentiate a curve or an equation, any graph, it gives you the gradient function. So, the differentiation gives you the gradient function, which is the rate of change. Okay. In a straight line graph, we know a straight line graph is in the form of y equals mx plus c. Okay, where m is the gradient of the graph. So we can see that the gradient of this graph is 2. Okay, because m is 2. Which means for every 1 unit you go over, it rises 2. And that's the rate of change. Now, on any straight line graph, the gradient is constant the whole way. But if we look over at this quadratic graph, if we wanted the gradient at this point, we would have to draw a tangent on it to show you the slope of the line. We know it's a negative gradient at that point. Okay? But if we wanted the gradient at this point here, we would draw a tangent at that point, and we would see that it's a positive gradient at that point. So the gradient is different no matter where, depending on where you go on the curve. And if you wanted the gradient at this bottom point, well, again, you would draw a tangent at the bottom point, and we would see that the gradient is 0. And that's at a turning point, any turning point in the curve, the lowest point to the highest turning point, the gradient is 0 because there is no slope on the line at a turning point. So, as I said, if you differentiate a curve, an equation, it would give you the gradient function. So let's take this first equation. Y equals 2x, so the derivative dy dx is equal to 2. So the gradient at any point on that curve is 2, and it never changes because there's no variable in there, there's no x, just at the constant 2. If we take the x squared curve here, we will have y equals x squared, but the derivative of that is equal to 2x. That means the gradient function for the curve is 2x. So to find the gradient at any point, you simply put in the x value that you're looking at the point where you're looking at the gradient, and it will tell you what the gradient is. So just say at this point is minus 2. Well, the gradient at minus 2 is, I'll just change this colour so we can see it easy, is 2 times minus 2, put minus 2 in for x, which is minus 4, which is indeed a negative gradient. If we wanted the gradient here at plus 2, well, we put into the derivative the x value of 2, so 2 times x, which equals 4, which is indeed positive. And again, at the point 0, if we want the gradient, dy dx is equal to 2x, so 2 times 0 is equal to 0, so the gradient is 0. So when you differentiate any equation from a graph, the derivative gives you the gradient function. Okay. So let's go into a few questions. Now, before I go into a few questions, when you differentiate and you're looking to find a stationary point or a turning point, the gradient at that point is 0. Okay. And to find the nature of the turning point, I'll just clear this bottom bit. So to find the nature of the turning point, you do what's called the second derivative. So on this x squared curve, if y was equal to x squared and dy dx was equal to 2x, well, the second derivative tells you the nature of the turning point. So d2y by dx squared is the notation for it, and differentiating this again, and that gives you 2. So the nature of the turning point, this number means two different things. If d2y, and I'll change the colour on that again, if d2y by dx squared is greater than 0, then the turning point is a minimum. Okay, you'd think it was a maximum, is greater than 0, but not. It's greater than 0 is a minimum. And if d2y by dx squared is less than 0, then the nature of the turning point is a maximum. Okay, so we know that d2y here on this x squared curve is 2, which is greater than 0, so we've got a minimum point, and we can see in our graph that it is the minimum point of the graph. Okay, so differentiate and put equal to 0 to find the stationary points, and differentiate again to get the second derivative to find the nature of the curve. Now, if you've got an equation for the second derivative like 2x, you would put in the x value. Okay, and we'll see that as we're going through some of the questions here. So I'm going to run through one question, and then I'm going to go through another two where we're going to pause it and work it out. So this first question, the curve is defined by that equation. Find the coordinates of the points where the curve meets the x-axis. Now, a curve meets the x-axis when y is equal to 0. Okay. So all we have to do is put in y equal to 0 in this curve. So we've x cubed minus 6x squared plus 9x is equal to 0. Now when you've got a cubic curve like this, we can first of all factorise out an x. So x comes out, and you've got x squared minus 6x plus 9 equals 0. And that'll give you a quadratic, which can then be factorised. So the quadratic factorises to x minus 3, x minus 3. Two numbers multiplied to give you 9, and add to give you minus 6 is minus 3. So if we want to find the coordinates where the curve meets the x-axis, it's where each of these is equal to 0. It's where x is equal to 0, x minus 3 is equal to 0, or x minus 3 is equal to 0, which is going to be the same point. So the coordinates are, we've got 0 for x here, so x is equal to 3, and x is equal to 3. Okay. Now, we don't need that last one because it's a repeat. Now, to find the y value of the coordinate, we just sub in the x value into the top equation. Okay. So, when x equals 0, y is equal to, well, 0 cubed minus 6 times 0 squared plus 9 times 0, which is 0. So we've got 0, 0 as our first coordinate, and then again, when x is equal to 3, y is equal to 3 cubed minus 6 times 3 squared plus 9 times 3, which is 0 as well. And easy way to look at that is, if it crosses the x-axis, y has to be 0. So there are your 2 points, and that's a repeated point. Now find the coordinates of the turning points of the curve. Okay, so let's just clear this here, and we'll find the coordinates of the turning points of the curve. Now, we know at a turning point the derivative is equal to 0. So if we differentiate this dy dx, it's equal to, differentiating 3x cubed is 3x squared minus 12x plus 9. So that's the derivative, and we can put that equal to 0. So we've got a quadratic. We can simplify the quadratic by dividing 3 by 3, and you get x squared plus 4x plus 3 is equal to 0. Okay, so then if we want to solve that to find the two values of x, we, two numbers multiply to give you 3 and add to give you 4, or add to give you minus 4. So that's x minus 1 and x minus 3 is equal to 0. Okay, so x minus 1 and x minus 3 is equal to 0. So that means x is equal to 1 or x is equal to 3. So the coordinate needs now the y values. So if we go into when x is equal to 1, we simply put it back. Do not put it back into the derivative. Put it back into the top curve to find your y value. So when x is equal to 1, y is equal to 1 cubed minus 6 times 1 squared plus 9. So y is equal to 4. Working that out. So our first coordinate is 1, 4. And when x is equal to 3, y is equal to, well, 3 cubed minus 6 times 3 squared plus 9 times 3, which is 0. And 3, 0. And that's the coordinates of our turning point, which is this part of the question here. Okay. Now, you're using calculus to identify each turning point as a maximum and minimum. This is where we differentiate again. Now, d2y by, or dy by dx was 3x squared minus 12x plus 9. X plus 9. So d2y by dx squared is equal to 6x minus 12. And that is our second derivative, which is our function for finding whether it's a minimum or maximum. Now, at the turning point 1, 4, at 1, 4, or where x is equal to 1, 6x minus 12, which is equal to 6 times 1 minus 12, which is minus 6, which is less than 0, so that's a maximum. Okay, and at x equal to 3, we've got 6 times 3 minus 12, which is 18, take away 12, which is 6, which is greater than 0, so it's a minimum. So we know that that is the minimum and that is the maximum. Okay? So that's how you run through stationary points, and then you'd be asked to sketch that, and you've got the 2 points where it crosses the axes, you've got the minimum points and you've got the maximum points and the turning points, so you can just sketch it. Okay, I want you to try question 10. Pause it. Now first of all you're going to have to write that y equals 5 over 2x squared plus 6 minus 40 over x all in one line, so the x will have to come up, and then find out the point with the tangent, find the coordinates of the point which the tangent of the curve is horizontal. On pause for the solution. Okay, first of all we're going to have to write this out where all the letters are up in the top line. So using our indice rules, the x comes up as minus 1. Okay, x to the minus 1. And now the derivative, dy dx, is equal to, well, 5 over 2 times 2 is 10 over 2. And the x, the squared, the power comes down by 1. Plus, well, the 6 is gone. So the minus 40 times the minus 1 is plus 40. And the power comes down by 1. And that gives you 5 plus 40, and drop it back down, over x squared. Now we know at a turning point that the line is horizontal when the derivative is equal to 0. The tangent is horizontal, okay, when it's equal to 0. So you've got 5 plus 40 over x squared is equal to 0. Now taking the 40x squared to one side, or 5 to one side, you've got 40 over x squared is equal to minus 5. That means 40 is equal to minus 5x squared. 5 minus 5x squared. We've got a problem here because we wouldn't get a negative number on the squared. Oh, we're missing an x here. That's 5x. 10 over 2 is 5x. Okay, so that's minus 5x, and that becomes minus 5x cubed. And then 40 divided by minus 5 is minus 8 is equal to x cubed. So that means x is equal to the cube root of 8, which is minus 2. Minus 2 by minus 2 by minus 2 is minus 8. Okay. So to find the coordinates, we put minus 2 back into the top equation to find the y value. So y is equal to 5 over 2 times minus 2 squared plus 6 minus 40 over minus 2. And minus 2 squared is 4, times 5 is 20, divided by 2 is 10, plus 6, minus and minus is plus, 40 divided by 2 is 20. So we've got 36. Okay, so your point is minus 2, 36. Okay, I want you to pause this one and run right through the question, seeing if you can work out these two parts, and then we'll go on to the next part, which is determine the nature of the turning point and draw on the curve. So I want you to do parts 1 and 2. Pause and unpause for the solution of the first two parts. Okay, write down the coordinates where the point meets the curve, or meets the x-axis. Straightforward, that's where y equals 0. So we already have it.